We learned a lot from the Apollo samples, but we still have a lot left to learn about the moon. The Apollo missions visited only a pretty narrow swath of the moon. All the missions were concentrated near the near-side equator. Really interesting and really critical insights were unlocked with the Apollo samples, but we have so many questions still to answer about the moon and the evolution of the moon.
Off of Artemis 1, we rise together back to the moon and beyond.
NASA's Artemis missions are NASA's plan to send people to the surface of the moon. We'll be sending people and roving assets and scientific equipment to, among other things, answer a lot of really compelling science questions. Scientists have a lot to learn about the moon. It's our nearest celestial neighbor here to Earth, so what the moon has experienced, we've experienced. Except here on Earth, we have things like plate tectonics, oceans, forests, people that erase the rock record. Whereas on the moon, that whole record of our planet's history, of the moon's history, is just kind of waiting there at the surface for us to explore. The South Pole, which is where Artemis missions are going to target, is specifically interesting for a couple key reasons. We think there are volatiles at the South Pole of the moon that are not present near the equator. Things like water and water ice that are trapped in the lunar regolith, which basically just means lunar soil, that can easily become untrapped from that lunar regolith, and scientists can scoop up and study for return to Earth. The Lunar South Pole is a really exciting scientific target, and it also comes with some challenges for operating. For example, the lighting environment will change drastically within the course of one mission, and even over sometimes the course of one spacewalk. So preparing the crew members, preparing the hardware that we're sending to the moon, and preparing the mission control teams is really, really important. The South Pole Aitken Basin is particularly exciting. We think it's one of the oldest and largest impact basins in the solar system. And if we can get the right rock from the South Pole Aitken Basin and bring it back to our labs here on Earth, we can use that sample to constrain the entire evolution of our solar system and really understand the timing of how the moon and our planet and the entire solar system evolved.